Okay, so I just want to give you lots of examples. So let's do this Taylor series for this function at this a value. So again, start by writing the function down, then take the derivative, and this is going to have chain rule. So 3 cosine of 3x. Take the second derivative, I carry this 3, take the derivative, I get negative sine of 3x times another 3, so I'll get negative 3 squared sine of 3x. So clean it up. Third derivative, carry along the negative 3 squared, take the derivative of sine and get cosine of 3x times a 3, so negative 3 cubed cosine of 3x. Fourth derivative, so I carry along the negative 3 cubed, take the derivative, and I get negative sine of 3x times a 3, so that gives me a positive 3 to the 4th sine of 3x. So let's put these, now put the value of a in, so f of pi over 2, so be careful, sine of 3 pi over 2, that's a negative 1. F prime of pi over 2, cosine of 3 pi over 2 is 0. Second derivative at pi over 2, sine of 3 pi over 2 gives me a negative 1, so it cancels with that negative, so I get a positive 3 squared. Third derivative at pi over 2 will give me a 0, cosine of 3 pi over 2 is 0. Fourth derivative at pi over 2, sine of 3 pi over 2 is a negative 1, so I get negative 3 to the 4th. So let's put it together. So I have negative 1 plus 0 times x minus 2 plus 3 squared x minus pi over 2 squared over 2 factorial plus 0 x minus pi over 2 cubed over 3 factorial minus 3 to the 4th x minus pi over 2 to the 4th over 4 factorial. So again, I'm going to rewrite it, eliminating the 0 terms. So negative 1, 3 squared x minus pi over 2 squared over 2 factorial. 0's gone, so minus 3 to the 4th x minus pi over 2 to the 4th over 4 factorial. All right. So again, I want n equals 0 to generate this, n equal 1, n equal 2. So I'm going to start off with the denominator, which I see is 2n factorial. Then I see this x minus pi over 2 to the 2n power. Then I see this factor of 3 that's to the 2n power. And then I've got that changing sign again. So if I start with n, if I use n equals 0, that gives me a positive 1. Oh, I need a negative 1. So I'm going to change that to a plus 1. So that's an n negative 1 to the n plus 1 there. All right, so let's move on to this next one. You remember the derivative of 3 to the x, correct? 3 to the x times ln of 3. Second derivative would be 3 to the x. I'm carrying along this ln of 3, and I have another factor of ln of 3, so that's the number ln of 3 squared. So to take the third derivative, I'm carrying along this ln of 3 squared. I take the derivative of 3 to the x, and I get 3 to the x times another ln of 3. So that's ln of 3 cubed. All right, I think I have the pattern, you think? All right, so let's go plug in a equals 0, because that's what Maclaurin says. 3 to the 0 is 1. Plug in a equals 0, I get ln of 3. Double prime of 0, I get ln of 3 squared. Third derivative at 0, I get ln of 3 cubed. All right, so my function will be 1 plus ln of 3 times x over 1 factorial plus ln of 3 squared times x squared over 2 factorial. Sorry, I probably shouldn't have put parentheses on that. So it should just be ln of 3, right? Then ln of 3 cubed, x cubed over 3 factorial. I get it. I see the pattern. So if I start at 0, x to the n factorial, and then the element of 3 factor, whoops, to the nth power, and that's the sum. All right, so let's look at the difference between a Taylor series with a equal 2 and a Maclaurin series. How much different is that? So let's start off with writing out what our derivatives are, right? I'll just do this kind of quickly because I need the list of them. ln of 3 squared, and I'll just go up to 3 because I see what they are. Okay, so now I'm plugging in 2, so I get 3 squared. So f prime of 2, I get 3 squared times ln of 3. Second derivative, I get 3 squared times another ln of 3 squared. So you can see that there's quite a bit of difference, right? So I get a factor of 3 growing. Oops, that's cubed. Okay, so let's put it together. So my first term would be 3 squared, then 3 squared ln of 3x over 1 factorial. Oh, sorry, x minus 2 over 1 factorial, because it's x minus a, plus 3 squared ln of 3 squared x minus 2 squared over 2 factorial. 3 cubed ln of 3 cubed x minus 2 cubed over 3 factorial. And it keeps going. All right, let's put it together. So I can see there's an n factorial. I'm going to start this one at 0. N factorial is growing, right? This would be n equals 0, n equal 1, n equal 2, n equal 3. What else do I see I have an x minus 2 to the nth power. I have an ln of 3 to the nth power. And I have a 3 to the nth power. So this Taylor series at a equal 2 looks quite a bit different than the Maclaurin series because that's a equals 0.